This conference will now be recorded.
Okay. Spark actually initially come up with the RDDs. Okay. So what happened when the Spark has been introduced? The first object which was introduced are RDDs, and how to um, evaluate or how to apply the transformations and actions and all comes on RDD. So if you take the Spark architecture, not architecture, I can say the Spark high-level diagram, it will be like this. You'll be having a core, Spark core. On top of that, you will be having a Spark SQL. You'll be having Spark streaming, and you'll be having graphics, and you'll be having Spark ML, and you'll be having Spark R. This is Spark core. Okay, where we all represent our data in the form of RDDs. Here, Spark SQL, where we'll represent all our data frames or data sets, and Spark streaming, where we have a Spark ML. I really didn't work on this. And where we have a graphics. It's a graph database, how to process the graph data is. And this is recently introduced Spark R. So these are the different libraries which support by Spark. Okay, so the Spark core is the base. Spark core is the base, and we can call the Spark core itself. We can call Spark engine also. We can call Spark engine because this is the core abstraction in Spark. Later, they have introduced a new libraries, Spark SQL, Spark Streaming, graphics, and other libraries has been added. These libraries are like simply plug and play. Whenever you need it, make use them. Okay, you really no need to install separately. You really no need to have separate configurations and everything. Okay, so these libraries are plug and play. So whenever you required, make use of it. It's a you can write a combination of Spark core as well as a Spark SQL, or Spark core, Spark SQL, Spark Stream. I don't know about the ML graphics and Spark R. I really didn't work with them. So because those are like a data science components, I really didn't work on these three components, and also I will not be covering these three components. These three components. Okay, we'll be covering these two components. Now, why the Spark SQL come into picture? So far whatever the Spark core we have seen, it is completely low level API where we have to where we have done this lot of programming, right? And going forward, what happened? See, the Spark core actually we used for a data where we do not have a schema and where we do not worry about the schema. Okay, so the Spark core, the RTDs we have used where we really do not worry about the schema, where we do not have a schema. or semi structured data. Where you really don't have a structured data also, we'll go with the RDD. But where you have a structured data, where you have a schema information, so then what we will do, we will use the new component Spark SQL. This is the one of the frequently asking interview question, guys. Okay, so when to when you'll use Spark SQL, when you use RDD, not Spark SQL directly, they'll ask when you'll use RDD, when you'll use data frames. Okay, so for that, I'll show you Databricks blog. I mean, it's official document only. Um, I'll show you a document. This is really nice. It's really nice, nicely explained. Okay, when you do not have schema, when you do not worry about a tale of three Apache API RDD data frame dataset. I don't know, today my network is slow, or I don't know. So it's very, I don't know what happened, guys. Okay, I'll ping this to chat group. This is the link. Okay, you guys can copy this and you can paste in the WhatsApp group also. Okay, if you look at here, RDD, resilient distributed data set, and if we come when to use and all it has mentioned, and if we come here, there is something called data frames. Okay, data frames which we are going to talk about. Okay, we have not yet started, and there is something called data sets which also we are going to talk about it. Okay, so the first one is RDD. We already completed this. Let's see a more detail about it. RDD was a primary user-facing API in Spark since its inception. At the core, an RDD is an immutable distributed collection of elements of your data, partitioned across the nodes in your cluster, that can be operated in parallel with a low-level API that offers transformation and actions. Okay, try to remember this on this definition. It's a very simple definition. Okay, now when to use RDD? So this is the right time to discuss about, because we have already discussed about RDD. We already seen about RDDs, right? Now let's see, understand when to use RDD. Can anyone tell me when to use RDD? Sorry, when to use RDD? I have already told. Look at here. Consider these scenarios are a common use case of using RDD when you want to low-level transformations and actions and control your data set. What is a low-level transformation and actions? The functional kind of transformation, like a map, flat map, float, fold, not float, fold left, fold right, reduce by key, group by key. These kind of low-level transformations when you want to apply. These kind of low-level transformations when you want to apply, will go with the RDD. Your data is unstructured, such as a media streams or stream of text. So guys, here the understanding of data like structure, semi-structure, unstructured. Okay, structure everyone knows. Can anyone tell me examples for the structured data? So what is the structured data? What is the structured data?
It has schema.
Okay, a data is properly divided by single delimiter. A data is properly divided by the single delimiter, and the whole data follows the same structure, same pattern. Okay, and if it has a schema, yeah, it can have a schema also. Okay, so as an examples, tables, CSV file, tab separated files, or your XML. Okay, coming to XML JSON, I'll put that in a different way. So your database tables, as I said, like a CSV, tab separated files, your comma separated files, your Excel sheets, right? These are all best examples for structured data. And when you categorize only two categories, like a structured and unstructured, and your JSON, your XML, your text, your other formats will comes under structure only. Spark actually sees in that way. For Spark, JSON, XML are structured. JSON, XML are also structured. Okay, but when you categorize your data into three categories: structure, semi-structure, unstructured. So the examples for the unstructured is where you will not be find any very common delimiter, or you will not find any schema. Okay, an example is your audio, video, image. Audio, video, and image. These are a best example for unstructured. Those are best example for unstructured. And coming to the semi-structure, the semi-structure one way, when you see that it's not very complex, and it will be having a some part of the data you will find a schema, some part will not, like that. Example, JSON, XML, okay, your text. These are the comes under logs, your emails. These all comes under semi-structure. But Spark sees differently. Spark actually sees such a way that your JSON, XML also structure, because Spark has that capability to read as a structure. Okay, so your data is unstructured, such as a media streams and stream of text. You want to manipulate your data with a functional programming construct, then domain specific expressions. You don't care about imposing schema, such as schema format while processing across the data attributes by name or columns. And you are getting right when to go with RDD. This is a very frequently asking interview question. That's the reason I have shown this document. I'm showing this document. I'm going through this. So you can go. You can for some optimization, forgo some optimization and performance benefits available with the data frames and data sets for structured and semi-structured data. Okay, so RDD does not have any optimization, and also RDD uses the Java serialization. Okay, in Spark 2.x, any changes in RDDs? Yes, there are some small changes, but not extensively. So our RDDs being regulated as second-class citizen? Are they being deprecated? No, they're not actually. RDDs are there always. So everything is on top of RDDs only. Okay. So talk about you guys. I can recommend you guys to go through this and try to remember this point, because the people will ask in interview this question. Next, when I have a structured data, when I'm loaded the structured data, when I have a schema, then we will go with the Spark SQL. What is the object for the Spark SQL? Object for the Spark SQL is data frames. Data frames. What is a data frame? Try to remember this definition, guys. Data frame also distributed collection of data, distributed collection of data with the named columns, with the named columns. Earlier we used to call data frames or schema RDDs. RDD does not have a schema. Now if you have a RDD plus schema, then we'll call it as a data frame. What is a data frame? Data frame is a distributed collection of data with the named columns. It means it looks similar to your tables in database. Looks similar to tables in your database. So whenever you have a structured data, it can be JSON, XML, or Hive data, or HBase data, whatever the data you are reading, or Parquet, other formats you are reading, because they are all bound with the schema. It will return you data frame. It will return you data frame. Let's look at here, guys. You can see SQL data frame data sets. Okay. Now look at here. This document is changed looks. Okay. Okay. So it is a module for the structured data processing. Okay. So it has its own object that's called data frame. Okay. So let's look at your data frame, data set or data frame. We'll talk about the data set little later. First, try to understand the data frame. The data set is a distributed collection of data. Data set is new interface added in the Spark 1.6. It is not on Spark 2. Most of the people think that it is from Spark 2. No, it is not Spark 2. It's there from Spark 1.6 itself. Spark 1.3 itself, I think 1.3 itself is the data frames over there. Okay, that provides the benefit of the RDD, strong typing, okay, ability to use the powerful Lambda functions. We'll discuss about this thing in later session about the data set. Okay, coming to the data frame. A data frame is a data set organized into named columns. Okay, so and otherwise I can simply tell you data frame is a distributed collection of data, with the named columns. It is conceptually equivalent to a table, a database table. Okay, but your data frames comes with the best or rich optimization technique, which is called catalyst optimization. Catalyst optimization. Okay, why this one? I'm expecting the different kind of document. That's the reason. Yeah, this is the document earlier. Later it has been changed. Okay, look at here the data, the Spark SQL. Look at here the data frame data set, same option here. So data frame is distributed collection of the data with the named columns. Okay, how to create a data frame? Now it's okay. How to create a data frame? So to create a data frame, there are different ways. Okay, let me ask you this question. How to create an RDD? How to create an RDD?
By reading the text file or parallelize method.
Only these two? Any other options?
By using a transformation on another RDD.
By applying the transformation on another RDD and create another RDD. Okay.
And we would use Spark context for that to create RDD.
Okay. So there is something called make RDD also. So there is something called make RDD. So that function is to create empty RDD. We'll use that. I think I have shown it. And one is a parallelize method. Another one is loading the data into uh, using Spark context. And other one is if you have already RDD is there, applying the transformations and creating another RDD. Similarly, we have some different ways to create a data frame. There are some different ways to create a data frame. Okay, so this kind of library will be available. Let's say if you are reading JSON, let's say spark.read.json. If you are reading parquet, spark.read.parquet. If you have Avro, we'll say spark.read.avro. Like that we will discuss. So, and as I told you, data frames are distributed collection of data with the named columns. It means it has a schema information. Okay, so let's go ahead and see some examples how we can create a data frames. Okay, okay. Before jumping into this, I want to show you some examples about the Spark, which comes by default with Spark installation. You can see inside examples. Especially SQL examples. Okay, Spark SQL examples. Look at here, guys. Look at here. This everything is common. Creating a Spark session and everything is common. Okay. The first method. I have a JSON file. I'm reading a JSON file. If I read a JSON file, by default, it gives me data frame. Spark.read.json. Spark.read.json. It gives me directly. It will give me in a data frame. Okay, that's the one way of doing it. And if you have, I mean, different kind of transformations. I'll show this kind of transformation, selecting the elements and age is greater than this, count, those things we'll see. Next, look at this one. I have a person class, case class. Try to remember here, guys. I have a person case class. The person case class you can see in the top. Case class, person, name and age, two fields. I have a case class which is person with the name and age. I don't think I need to explain what is the case class. So, and also another limitation of the case class and a tuple in Java in Scala, it will support up to 22 fields only. You cannot give more than 22 fields. It means you cannot give more than 22 columns. Okay. So this is one of the limitation. Keep in mind that if anyone asks an interview, you can tell that. Tuple also has the same. Tuple also can have only 22 fields. Similarly, case class also you can have only 22 fields. Next, come down. Sequence. What is a sequence? What is a CQ? SEQ? We discussed about while talking about collections. So under CQ, what are the collection classes will come and everything we discussed. It's a collection, right? CQ is one of the collection, sequence collection. So in that I have one object. This is one object, person object. I have an object called person object, and here if you see the dot to ds, it is not a data frame, it's a data set. Okay, it is a data set. So if you have a collection of objects like this, from that also you can create a data frame. From that also you can create a data frame. There is another way reading from the JSON. There is another way reading from the Parquet file. Okay, or you have one way you have read using the text file. It has a comma separated. It has a comma separated. Look at, yes, this is important. You have a text file. You have a text file with the comma separate. Let me show you the text file also. I don't know what happened. What is the resources? SRC main resources. SRC main resources. Sorry, I missed it. Resources. People.text. This is a file. Okay, this is the data file. It has a comma separated values, name and age, right? Name and age. So if you see here, I'm reading my text file with the help of the same spark context dot text file. When I do, what will happen here? When I do with what will happen? It gives me RDD, correct? It gives me RDD. I'm doing a map transformation on top of it. When I do the map transformations, what it does? It will divide the fields based on the comma and it will returns you tuple. Then I'm applying one more map transformation. On that element, I'm returning an object, person object. Look at here. I'm creating a person object. What is a person? Person is a case class. Person is a case class. In that, I have normally if you want to create an object, what you will do in Scala, Java, or something, you'll specify new and the class name and what are the parameters has to pass will pass. Similarly, the case class also you can create an object without new keyword. So here what I'm doing for every row, for every record, I'm creating one object. Look at here, person object. So in the it has been splitted right by comma. 0th position I have a name. The first position I have a integer. So the 0th position, if it is a string, I really no need to specify explicitly to string or something. If it is an integer of any numeric type, I'll specify that I'll convert into integer type. Now what I have done here, I have created collection of objects like this. This is the first row, then again second row, again third row. Like that, I will be keep getting the rows, right? Then at the last, 2df, 2df, 2 data frame, 2df, convert to data frame. The sequence of objects you are converting to data frame, 2df function, converting this to data frame. Then once you got the data frame, and you can here another thing is the data frames, you can create a temporary table or a view with the help of the create or replace temporary view. What it does internally, it will create some kind of a temporary table. When it creates a temporary table, you can directly use Spark SQLs like this. You can directly use a Spark SQL queries here. Okay, if you have a temporary view or a table, You can directly apply this one. Okay, so I mean, I think I'm not making you confused by showing this. Don't get confused. I will show you very simplest way to create a data frames and how we'll do. Let's look at that. Create a data frame. So we have an example for that. Okay, look at here, guys. But for whatever we should need a data, right? We should need a structured data in that case. We need a structured data. Okay, so here let's take an example. I'm taking some data here, which is a sequence, a collection of data. Sequence is a collection of data, guys. So there are different ways. I'm showing you a first way here. Look at here, employee data. So some salaries, okay, for employee for different months. Okay, some employee data for the different months. Okay, so you can take some examples here. This is a data collection of data, and also it has to be structured data. Okay, that's what I have done here. Employee name, month, salary. Employee name, month, salary, or employee name, month income, whatever you call it. Okay, for that month income. Okay, look at here. These are the columns I need. These are the columns I need. This is my data, and this is my columns, the columns which I'm looking for structure. Now, with the help of the 2df, that's one way of reading it. That's one way of creating a data frame with the help of the 2df function. Look at here, sc.parallelize employee data. When I do sc.parallelize, I will get rdd. I will get rdd. That rdd I'm converting to data frame 2df. So whatever the 2df function you have seen here, it does not take any arguments. It does not take any arguments. It's empty because you are not passing any column name information here. But this object already has it. This object already has it, age and name. But here explicitly I'm specifying my, so don't get confused. This is a one way of expression to take all the columns. Okay, so one way of expression, columns colon underscore star means all the columns. It will take all the columns. Okay, 2df of in double quotes employee name comma in double quotes month comma income. This is equivalent to 2df of income, month, name. Okay, so don't get confused. This is equivalent to this. Then we got the data frame because you converted 2df function. With the help of the 2df function, you have converted. I have not written any case class here. Try to look at. Okay, case class is not really required for all the cases. Okay, so I have created employee data frame. I am doing the schema show. Okay, let me execute this example on console and let me show you what happens. Any questions so far? Any questions? System is struggling a lot. Okay, it's a data sequence of data. Nothing else. It's a collection of data. Look at here. It's a collection of data, and it's just a collection of strings. The actual stuff comes from here. Whenever you're using 2df, you have to use implicits. It's loading. Look at here. When I say print schema, it prints the schema information. of that data frame. Okay, this data frame has name, month, income. And when I try to do this one, show is kind of an action which will display the your data frames content, but it will display only 20 rows by default. And also if these are not lengthy strings, these are simple strings. That's the reason you are able to see the full name or full column value. It will actually not show the full column value. So there are different ways of show function. There are different ways of the show function. We'll see that also later. Any questions so far about creating a data frame?
Hi Ravi, Chandu
Yeah,
here.
yeah.
I have a doubt here. Like when you print the schema,
Mhm.
uh, there is a factor for nullable equal to true. What is that? Can you explain that? And how did you create that?
So I didn't create this. Okay, by default, when you create any column to the table, right? So there will be some properties, whether it can be nullable or not. Nullable means employee name can employee name can get uh, null value or not. Month column can get a null value or not. Integer income column can get null or not. By default, if you are using 2D function, they are nullable true. And if you see that integer column, is nullable true, it's come as nullable false because it's an integer column. The first two are string columns, the second one is integer column, so it came as a false.
So every time the string will come as a nullable true and integer as false, or
Integers always comes zero, right? It will not come null, no. Integer
okay,
has to either zero or something, right? It will not be null, right? That is the reason.
okay. It depends on the data type.
Yes.
Okay, got it. Thank you.
Okay, any other question?
Ravi, the implicit for import, so what it does, Ravi?
Okay, implicit imports unnecessarily importing all the information. Whatever you are going to use here, like a 2D function, those things, it will be import. So there is something called implicit imports. We'll talk about this in the later session in detail about it. There are something called implicits. Okay,
Sure,
what
sir,
is the
thank you.
difference between implicits and explicits? We'll discuss about that. It's just Scala. It's not belong to Spark one. It's a Scala one. So this is the one way of creating it. Okay, you have a collection of data or you have a RDD. That RDD were converted into data frame by using 2DF function. 2DF function. Okay, and another way of creating it. There is a function called create a data frame. There is a function called create a data frame. Here I created RDD and I convert into data frame. But here is not like that. You have a data, use a create data frame function and just call 2DF function. 2DF function is your converting to data frame and supplying the schema information. Okay, so same thing you can do here also. Okay, and cdf dot show. This is another way of creating a data frame. This is another way of creating a data. There is a one more way, okay, like directly using today, but it has to be sequence of data. It has to be like this. It has to be like this. Sequence, collection of data. Okay. There is a one more way. So far we have seen collection of tuples. Look at here, sequence of tuples. Tuples. But if you have a collection of row, it comes under here. In SQL data type .SQL, you have a specific class called row. Okay. Row is a one object. Okay, so I can say it's one type. Okay, in this row, if you have a collection of rows, you can directly make use of a collection of rows to a data frame. Okay, so far we have provided schema with the help of the 2DF function or a case class. Using case class also we did know the previous example I shown. There is an alternative way to provide a schema information with the help of the struct field. This is another important one. Please try to remember this. Struct field. Struct field is your structure field. Struct type. At the end will be having one thing, something called struct type. It is a structure type. Okay, you'll create a list of fields. First field, second field, third field. First field is employee field. Its data type is string type and it can be nullable. Second field is a month. It is a string type. It can be nullable. Third field is income. It is an integer type. It can be nullable. Nullable means here 0. Okay, look at here. You can look at this. Name. First parameter is name. Second parameter is data type. Third parameter is nullable. And fourth parameter is metadata. I haven't used any time, but anyway, I can check this later. Struct field. Okay, here is our row. Row was still is importing. Yeah, it's done. Row type. It has some methods. Apply from sequence, from tuple, merge. So if you have a rows of data, sequence of rows or collection of rows, row type, row object, collection of row object. With the help of that also we can create a data frame. So earlier we have used a 2DF function, right? Now I'm not going to use a 2DF function. I'm going to use a, these two lines, actually I call it as a preparing my schema. These two variables, I can call it as a preparing my schema. This is my column types. I'm attaching that to struct type. So I prepared my schema. With the help of the create data frame. So what I done here, create a data frame. I used 2DF function by passing the data. Here, create data frame. I'll pass my data and the schema. I'll pass my data and my schema. My data has to be row data, row objects. The data has to be row object, not the normal object. It has to be row object. Then only you can create a data frame. This create data frame functions, let me show you. This is one, right? This is another one. You can say control F12. It will show all the methods in that object or class. Control F12. It will show all the methods. If you look at the create data frame, this is one method, one form of method. Create a data frame from RDD after product. I mean, some example just giving with the help of the case class tuples. Okay, here RDD I have. So here it is creating a data frame with the help of the RDD. Okay, similarly, create a data frame from the local sequence product. Sequence means collection of data. This is one way of doing it. I hope you guys are following the different forms of create data frame method. I'm showing you in the source code. Okay, create data frame is a method which is in Spark SQL. Okay, which is in a Spark SQL. So Spark SQL, Spark session actually. Okay, create a data frame. What you are trying to do in Spark session, from the Spark session, you have a different forms of the create data frame. One is with the create RDD, one is with the create of sequence of data, another one is create from RDD and schema, create a row of data and schema like that. Look at here. One more API here. Row RDD comma schema. Row RDD comma schema and create data frame. Row RDD comma schema. This is Java RDD. This is a different type. Okay, struct type. The schema data type is struct type. Create data frame with the rows, list of rows. Look at here, list of rows and schema. Okay, so like this you have a different forms of create data frame, different forms of create data frame. So you can create data frame in these many ways. Okay, so look at here, we can have a look. So many methods are there with the create data frame. Method overloading, the best example for method overloading. Okay, earlier we have seen with simple data. Now I am showing you the collection of rows. Sorry, here. Collection of row RDD. Row RDD. I cannot say collection of rows. It's a row RDD and schema. Okay, and other ways are reading from the data, like from the CSV file or from the JSON file or from the Parquet file. Different ways. So you can read the data from the different other sources, and you can create a data frames also. Any questions so far, guys? Any questions so far? Optimization technique and all we'll discuss. First, I want to make you comfort with these data frames. Then I'll tell you internally how the optimization technique will work. I already have some PPTs. Okay, this was the PPT. So I can show this PPT. I can share this PPT also. In this PPT, how this catalyst optimization has been applied, and those things I will show you. Okay. So first, get familiarity with your data frames. Then we will discuss more on it. It is a frequently asking interview question, guys. When to use RDD, when to use a data frame, when to use a data set. Okay, try understand this one. This is the most important, the link which I have given earlier. Try to read this. Now coming to the data frame, look at here, guys. Coming to the data frame, anyway we have introduced and we understand what is a data frame. Data frame also an object which is a distributed collection of data with the named columns. It means schema is bound with it. Okay, like an RDD, data frame is a immutable distributed collection of data. Unlike an RDD, the data is organized into named columns like a table in the relational database. Designed to make a large data sets processing or even easier, data frames allows the developers to impose a structure into a distributed collection of data, allowing a high level abstraction. It provides a domain-specific language API. What is the domain-specific language API? So very simple, guys. When I say domain-specific language API, suppose if I want to read the data from RDBMS, it will connect and read the data from RDBMS. Suppose if I want to connect the data from Hive table, it can understand the Hive thing. Suppose if I want to read the data from the ORC Parquet file, it can understand that and read it. If I want to read the data from the CSV file, it understands and reads. So that's called domain specific, which from where you are reading the data, it can easily understand to that domain and read, process data. Okay, so if you look at this, okay, so this is data frame API diagram. Data frame and data sets, will talk about these things. So data sets are actually typed API. Data frames are untyped API. Data frame does not have any type specific. I will talk about it. What is a type specific? What is a not type specific? Okay, data sets is a type. I'll tell you what is a type. Okay, data frames are distributed collection of data with the named columns. But underneath of the data frame again is RDD, guys. So on top of RDD only, the data frames has been introduced by providing a schema to it, by providing some optimization to it. Okay, any questions?
Can we connect ORM tools as well from here instead of
Can we connect?
SQL? ORM, Hibernate or JPA something.
See, even they, no. ORM is what? Object relational model. It is not a database, right? Hibernate is not a database, right? Hibernate is a way to connect to a database and get the data, right?
Yeah, yeah,
Not correct,
correct.
right? So Spark, see, what is the advantage of the Hibernate? I mean, that's again a different concept. You can connect
Yeah,
to any
that is
database.
connect
You have a
any
yeah,
database.
yes, any database. You have a different dialects will be there. I know
Yeah,
it will create a lazy evaluation,
yeah,
right? Hibernate is a lazy connections. It will not directly go and connect and get the data. It can be
yeah.
cache. There are different kind of cache levels in it, correct? The Hibernate,
Yes, sir. Yeah.
but Hibernate is not required for the Spark. The Spark can directly connect to the RDBMS and read the data.
Okay.
Okay, that is about it. Data sets and all we'll discuss in very detail later point, not at this point. So if you guys have any questions, please ask me. Else we can leave for the day today. So tomorrow I want everyone to have a setup and we'll start read this one, process this data, creating RDD, creating data frames and all. We'll see. And also once the data frame is created, we can apply a lot of transformations. We'll see all that what are the transformations we can. And also let me show the last one. This one point. Scala, examples, SQL. It will different data sources we can read. Example I want to show. But these examples I'm showing from your Spark only, guys. Okay, Spark installation from this, wherever you have installed Spark, there only it will be. Okay, they reading Spark it. It has a load API, the spark.read.load, and you can give it to a Parquet. That's one way of reading it. While writing also you can specify that, okay, what format you want to write. Reading JSON, this is one way of reading it by the help of the spark.read.format using load. Earlier spark.read.json directly you can apply the path. Okay, another one is this is SQL directly. If you want to apply the SQL directly, if you have to create either temporary view or table, but if you have a Parquet table, Parquet dot they are doing. Okay, I have not applied this Parquet dot this stuff. You guys can try once, and you are applying your by bucketed, by sort, by all the transformations you are applying. Okay, partition by also it is there. You are saving into table. Okay, save as table. You are save as table. The data frame is partitioned by and bucketed by and writing into table. Okay, apart from this, read Parquet, spark.read.json, write into Parquet, dataframe.write.parquet. Look at here, you're writing into Parquet. Then you can read from the Parquet, spark.read.parquet. Okay, so you can use this kind of different data sources. You can connect and read it. So JDBC is not there. JDBC should be there. I think JDBC also there here. If it is not there, anyway, I have an example to show the JDBC, how we can connect to JDBC, how we'll read. Yeah, JDBC is there. Look at here. You can connect to the database with the help of the JDBC. You pass URL, your JDBC URL. It's normally we'll call it a driver. your database schema and the table, your username, password, user load. Then you'll get the data frame. Or you can use directly like this: spark.read.jdbc and pass this and pass this and pass this connection properties. Connection properties are nothing but username, password. Okay, these are the different ways to read and write into database. You can read from the database and you can write also database. Any questions so far? Okay, so that's it for now. Let's connect in the next session. We'll discuss in detail about data frames and we'll see more examples. Thank you guys. Thanks for your time. Have a wonderful day. We'll connect in the next session.